All right, so we're gonna pick back up here. I missed your question, Elon. Yeah, my finger is mostly recovered. It's a little scarred. The fingertips are a little scarred at the end, but I'm not like spurting blood out of my fingertips anymore. So that's good. Thanks for asking. Thanks for checking in on my health. I appreciate that. All right, so where were we? The math with, you guys are trying to distract me now so we don't get any work done. I'm not doing math with fruit. I'm using the little stylus pen that comes with my laptop, Nick. Now let's get back to work. We have -3/4 minus 6/4, which is going to be what? Anybody? Oh, good, Nick. All right, -9/4. We'll cancel the negatives, we'll cancel the 4s, and we get just √3/9 as our slope. Everybody agree with that? Everybody feel okay about that? Did any of you like miss too much that I need to go back and talk about? It was mostly just me doing arithmetic and plugging in trig values when it was cutting out for people. So everybody all right or no? Everybody's good? Except those of you that are traumatized from looking at my website, apparently. Y minus 3/8 equals √3/9 times x minus 3√3/8. There's our equation. Everybody good there? Any questions? Shayla, did that help out? Is that helpful to see another one of those? Even though it's...
Thank you.
Yeah, no problem. Happy to. Anybody else have any questions on just finding the tangent lines for polar or parametric graphs or for regular graphs? Okay. You guys get started on that tangent line. I know some of you got started on the tangent line assignment because I had some questions from people yesterday, but is that going all right? Yeah, so far so good. Okay, cool. All right, let's specifically talk about horizontal and vertical tangent lines. So we know that if the derivative of a function is equal to 0 for any values in its domain, it should have a horizontal tangent line. And if the derivative of a function is undefined for any of the values in its domain, it should have a vertical tangent line at that value, right? Should be good with that, I hope. Yeah, that's what you learned last year. So can we find any horizontal and vertical tangent lines for these two equations? The answer is yes. So first we'll take the derivative. Derivative of 2x cubed minus 3x squared plus 5 is 6x squared minus 6x. And first off, this is never undefined, right? So does this one have any vertical tangent lines? Nope. And we'll set it equal to 0. Factor out the 6x and be left with x minus 1. So we got x equals 0, x equals 1. So those are the locations of the horizontal tangent lines. It says to find the tangent lines. So what do we have to do with each of those values? We should plug those in, right? So f of 0 is 5, and f of 1 is, what is that, 2 minus 3 is -1 plus 5 is 4. So our equations are y equals 5 and y equals 4. Everybody good with that? Adrian, at corners, no, there's no vertical tangent lines. At cusps, there are also not vertical tangent lines because the cusps show up. Well, let me think about that. Cusps at a vertical tangent line. I would say in general, no, you don't have vertical tangents at cusps. Yeah, but let's say, yeah, we do. Yeah, cusps are vertical tangent lines, but corners are not. Any other questions on that one? All right, so let's do this one. Let's find our derivative. F prime of x, derivative of cube root of x plus 5, that's x plus 5 to the 1/3, so that should be 1/3 x plus 5 to the negative 2/3. So we'll put an x plus 5 to the 2/3 in the denominator, and then minus 1. And what makes this undefined? When our denominator is equal to 0, right? Which would be at x equals what? Should be x equals -5. And so that will be the equation of our vertical tangent line. And then what about horizontal tangent line? We need to set the whole thing equal to 0. If you want to get a common denominator, you can, but if we just set it equal to 0, that's going to give us 1/3 times x plus 5 to the 2/3 equals 1. And we'll cross multiply here, bring the x plus 5 up here. So we'll have 1/3 equals x plus 5 to the 2/3. And we'll have to cube both sides and then take the square root. So x plus 5 equals 1/3 cubed, which is 1/27. So the square root of 1/27 minus 5. And that's when that'll occur. And we just then need to plug that in up here to figure out what the actual horizontal tangent line is. So we'll say f of -5 plus 1/√27 is what do we get? If that's our x value, -5 plus the 5 cancels out. So we just have the cube root of 1/√27, which is, that's already being square rooted. So if we have it to the 1/2 and we're going to take it also to the 1/3, that'll be to the 1/6. So 1/6 root of 27, and then minus this, so plus 5 minus 1/√27. So y equals that will be our horizontal tangent line. Kind of a pain, but we can find it. Everybody good there? Any issues there? All right, let's do this one. We want to find all horizontal and vertical tangent lines for this equation. So first thing we're going to do is do what? Take a derivative, right? We'll take the derivative of this how? Should be doing this implicitly, right? So 2x plus x dy dx plus y plus 2y dy dx equals 0 if you take the derivative with respect to x. And what do we end up with there? Then we got negative, so we say dy dx equals -2x minus y over x plus 2y. Everybody agree on that one or no? So far? So then, if we want to find horizontal tangent lines, what does that tell us? It tells us that the numerator, negative 2x minus y, needs to equal 0, or that y equals negative 2x. And so how do we figure out when y equals negative 2x? We should take that and plug it back in to our original equation. So y equals negative 2x means that we've got x squared, and then y is negative 2x, that'll be a minus 2x squared. And then the y squared will be a positive 4x squared equals 6. And so we'll solve this. X squared minus 2x squared is negative x squared, plus the 4x squared is 3x squared equals 6. So x squared equals 2, or x equals plus or minus root 2. So those are x values at which we might have horizontal tangent lines. Okay. So we're going to take a look at that in just a second. But first, we're going to go in and we're going to do the denominator. So I'm going to also solve the denominator for y. So if I've got x plus 2y equals 0, that's going to be y is equal to negative x over 2, or negative 1/2 x. So we'll plug that in up here to give us x squared, and then minus 1/2 x squared, and then plus 1/4 x squared equals 6. And simplifying that down, we got a 1/2 x squared plus a 3/4 x squared, right? Equals 6, or x squared equals 8, or x equals plus or minus 2 root 2. So one thing when we're doing implicit functions that we need to be careful about, and the reason why I went through and did both the denominator and the numerator before I actually wrote the equations of the lines, is that if there's overlap here, if the same x value makes both the numerator and the denominator equal to 0, then that means that there is not a horizontal or a vertical tangent line there. So we got to be careful with that. We got to make sure that the same values here don't give us those tangent lines. Everybody good with that? So if this had like a positive root 2 and this had a positive root 2, I would ignore that from both of them. Good? Okay. What is what? What does that mean, Kiana? I don't know what that means. Is that a what that you've spelled in a different way? Is that okay? Yeah, so suppose this had come out to be x equals plus or minus root 2, and this had also come out to be x equals plus or minus root 2. Then that would mean that there weren't horizontal or vertical tangent lines there, because the derivative wouldn't be 0. It also wouldn't be undefined. It would be indeterminate, those values. It would be 0 over 0. Does that make sense? Okay, cool. So if we plug in positive or negative root 2 in here to solve for y, we should be able to get the equations of the horizontal tangent lines. These should be the equations of the vertical tangent lines. So let's do that. We plug in root 2. In fact, I'll do this on a new page. We have x squared plus xy plus y squared equals 6, right? And x equals plus or minus root 2. So if we put in positive root 2, that's going to become 2 plus y root 2 plus y squared equals 6. And then we'll have to solve that. How do we solve that? What is this equation right here? It's just a just a quadratic, right? So if I set equal to 0, if I subtract the 6, we got y squared. Y squared plus y root 2 minus 4 equals 0. And we can use the quadratic formula on it. So negative root 2 plus or minus the square root of b squared minus 4 times a times c, so plus 16 all over 2. And you know, there's our values. We'll plug them back in and figure out what works. If we do the negative root 2, we're going to get the same thing here. This will give us 2 minus y root 2 plus the y squared equals 6, and we'll do the same thing. So that'll become y squared minus y root 2 minus 4 equals 0. And now it becomes positive root 2 plus or minus. Same thing. Everybody good with that? What does the graph look like? Let's see here. Let me pull up Desmos. So it should be x squared plus xy plus y squared equals, what was it equal to, 6? So what was our, we had x equals, what do we have? X equals root 2. Right? No, we had x equals 2 root 2. There we go. And x equals negative 2 root 2. Yeah. And then what was our first y value there? Y equals, we had root 2 what do we have? Plus, what was it, root 18? Divided by and then the same with the yeah, I can put in the other one, but same thing. Everybody good there? Alternatively, rather than doing it this way, we could have gone in here and we could have then said, well, at what y values does this have horizontal tangent lines? And we could have solved this for x equals negative y over 2. And we'd see that we'd end up with, I believe it comes out to be 2 root 2 again. I believe that's the same value, but I could be wrong. Should be. So I believe y equals 2 root 2 is the same as that that longer thing that I just typed in into Desmos. All right, so same thing we just talked about here with this implicit one, but for parametric functions, dy dt equals 0, so the numerator of dy dx equals 0, but dx dt does not equal 0, gives us a horizontal tangent line, and vice versa. Dx dt equaling 0, but dy dt not being 0 gives you a vertical tangent line. But if they're both equal to 0, then you don't have a vertical or horizontal tangent line at that point. Okay. Everybody good with that idea? Hopefully. So let's find dy dt. What's dy dt equal? Looks like it's just 6t. And what's dx dt equal to? 3t squared minus 3. So when does dy dt equal 0? When t is 0. And when does dx dt equal 0? If you take the 3 out of that, it's t squared minus 1. So t equals plus or minus 1. So for this one, doesn't look like there's no overlap, right? So we should have horizontal tangent line at t equals 0 and a vertical tangent line at t equals plus or minus 1. And so how do we find the horizontal tangent line when t is 0? Where do we need to plug that t equals 0 in? We plug it in both places or one or the other? Where do we plug in t equals 0 to find the horizontal tangent line? Yeah, that's right. We'll plug it into the y one because it's a horizontal tangent line. So y of 0 equals -9. So we got y equals -9. Everybody see why we plug it into the y one, right? Because that's the equation of a horizontal line. Y equals, right? Plug it into the y. And for t equals 1 and t equals -1, we'll plug it into the x. So x of 1, what is x of 1 equal to? Looks like that's -2. And x of -1 should be +2. So we got x equals 2 and x equals -2. And if we want to graph this, we could do that in Desmos. We got t cubed minus 3t. And what was the other one? 3t, was it 3t squared minus something? -9, I think. And so let's say we're going to go from -10 to +10. So that's what our graph is going to look like, basically. And we had a horizontal tangent line of y equals -9, which we can see at the bottom there, and vertical tangent lines of x equals -2 and x equals 2. And there they are. Everybody good with that? Any questions there? All right, let's do another one. T cubed for x and sine t for y. So first, let's find dy dt. What's dy dt? Should just be cosine t, right? Yep. And what's dx dt? Should just be 3t squared. And let's restrict this to t is less than or equal to 2 pi, greater than or equal to 0. So we'll just go from 0 to 2 pi here. When does cosine t or dy dt equal 0 on that interval? At t equals what? Pi over 2 and 3 pi over 2. And when does 3t squared equal 0 at t equals 0? No overlap, so we can just go right in and figure out what these values are. So at t equals pi over 2, we're talking about a horizontal tangent line. What's the sine of pi over 2? be 1, and the sine of 3 pi over 2 is negative 1. And at t equals 0, that should give us x equals 0. So let's take a look at the graph. T cubed sine t 0 to 2 pi. And what do we say we had? X equals 0, right? We can see that right there. And our other one was y equals, what was it? Y equals 1. And then we also had y equals negative 1, which we're going to have to zoom out a bit somewhere over here. You can see that that's likely what's happening here, somewhere out here. I don't know exactly where, but you can see that that purple one goes back up above the blue one. Everybody see that? Hopefully. Any questions or issues on that? All right, let's do one with polar. We got about 15 minutes, so with any luck, that'll be enough time for this one. It's a little bit time consuming. So we're just looking for the horizontal tangent lines of r equals 3 plus 8 sine theta. So what's the first thing we should do? Split into the x and y, good. So we've got x equals what? X is r times cosine theta, so we got 3 plus 8 sine theta times cosine theta. And we've got y equals 3 plus 8 sine theta times sine theta. Everybody good with that? Yeah? Okay. So then we need to figure out what dy d theta is for our horizontal tangent line. So we'll start with that. Dy d theta should be the derivative of this, which is 3 plus 8 sine theta times the derivative of sine, which is cosine theta, plus sine theta times the derivative of 3 plus 8 sine theta, which should be 8 cosine theta. Everybody agree with that being dy d theta? Yep, okay, good. So then we should be able to simplify this down. We got 3, if we distribute the cosine through, we got 3 cosine theta plus 8 sine theta cosine theta plus another 8 sine theta cosine theta, which should be plus 16 sine theta cosine theta. And how are we going to set this equal to 0? How are we going to solve that? All right, so Adrian, we can't divide by cosine because sometimes cosine is equal to 0. And so we can't just assume that we don't have a theta value of pi over 2 or something like that. But we can factor out the cosine value, yeah. So we're going to factor it out. That's right, Shayla. So we'll factor out cosine theta, and that'll be 3 plus 16 sine theta equals 0. And then we'll use a zero product property and get cosine theta equals 0, and 3 plus 16 sine theta equals 0. So theta should be what for this. And we'll just talk about for theta is less than or equal to 2 pi greater than or equal to 0. What should theta be here? Cosine theta equals 0 should be pi over 2 and 3 pi over 2. Yep. And then what about this one? This one should give us sine of theta equals negative 3/16. Now that's not a unit circle value, is it? I don't believe so. Where does this angle occur between 0 and 2 pi? It should occur twice. The angle, there should be two different angles between 0 and 2 pi that give me negative 3/16 when I take their sine. What quadrants will they be in? Should be in the third and fourth quadrants. Yep. Okay. So let's just quickly draw a little picture here. I'm going to have an angle somewhere in here and an angle somewhere in here. And for both of them, the sine of that theta needs to be negative 3/16, which means that the reference angle for whatever theta is, so we're going to say the reference angle of theta has a sine of, we'll say the reference angle of theta is equal to theta. Normally you use a prime for it, but we'll just call it theta 1 for now. So we'll say the sine of theta 1 should equal 3/16. And here is a value of theta 1, and here is, I don't know why I did that backwards. Here is an angle, just that little angle should be the same value as theta 1, and this little angle should also be the same value as theta 1. And so if we're talking about the actual angle measure of the one that goes into the third quadrant, from here to here, that one should be pi plus whatever the angle of theta 1 is, and theta 1 is the inverse sine of 3/16. So this blue angle should be pi plus the inverse sine of 3/16. And this other angle, which I'll draw in red, should be the full 2 pi minus theta 1. So 2 pi minus inverse sine of 3/16. Everybody good with that? Everybody remembers their trig that they never learned? I mean, the trig that you know so well? Sorry, misspoke there. OFC, is that of course? Is that what that's supposed to mean? Or is that like some sort of, I don't even know. Yeah, Mahika, I'll go back to the other page, and then Shayla, I'll answer your question after that. Might as well write those other two angles in now that we've got them. Good there so far. Who was that? Was that Mahika that asked me to go back, I think? Yeah, Mahika, you good on that page? Yeah. Okay. So Shayla, the negative 3/16, it becomes positive. It doesn't exactly become positive, but we're trying to find an angle that has a sine of negative 3/16. So if the angle that we're looking for has a sine of negative 3/16, its reference angle, which, reference angle, if you remember, is just the angle, is an angle in the first quadrant, it's an angle that's less than 90 degrees. So the reference angle that has a similar sine is the one in the first quadrant that has a sine equal to 3/16, and that angle is whatever the inverse sine of 3/16 is. And so we use that as our reference angle. Our reference angle is inverse sine of 3/16 to say that I need to go pi plus another inverse sine of 3/16 to have a reference angle of inverse sine of 3/16, or I need to go a full 2 pi and then subtract off that reference angle of inverse sine of 3/16. to still get negative 3/16 when I take the sine of each of those angles. So if you have, if you happen to have your graphing calculator on you, you could input into it, you could put in sine of pi plus inverse sine of 3/16, and it should give you out negative 3/16 as your result. And same with sine of 2 pi minus inverse sine of 3/16. It should give you negative 3/16. Does that make sense, Shayla, or no? Okay, cool. All right, so we've done some good work here, but we've done this as if it's an implicit function. And so we have to make sure that dx d theta doesn't equal 0 to any of these values also. So let's real quickly, we're going to need some more pages here, but let's figure out what dx d theta is. So dx d theta, let's see, what was x? It was 3 plus, what was it, 3 plus 8 sine theta? Or is it cosine theta? Now I don't even remember. Sine theta times cosine theta. So as we take the derivative of this, we should get 3 plus 8 sine theta times the derivative of cosine theta, which is negative sine theta, and then plus the derivative of 3 plus 8 sine theta, which is 8 cosine theta, times cosine theta, so cosine squared theta. And then we end up with this equals negative 3 sine theta plus 8 sine squared theta plus 8 cosine squared theta. Everybody agree with that derivative for dx d theta? Oh, sorry, not this should be a minus 8 sine squared theta, not plus. That eraser is a little bit big. All right, everybody good with that? And we could simplify 8 cosine squared theta minus 8 sine squared theta into 8 cosine 2 theta. But that's not super helpful there, right? Because now how am I going to solve this? So what other form of cosine of 2 theta do you think would be helpful for us to use? Probably the one that says 1 minus 2 sine squared theta, put it all in terms of sine. And that gives us 8 minus 16 sine squared theta minus 3 sine theta. And so if we're looking at when that equals 0, this is just effectively, it's a quadratic, right? It's negative 16 u squared minus 3u plus 8 equals 0 with u equal to sine theta. So if we solve this for sine, we should get 3 plus, or sorry, for u, we should get 3 plus or minus square root of 9 plus, let's see, what's 4 times 8 times 16? That should be 512, I think. All divided by negative 32. You guys agree with me on my arithmetic there? At 512? Okay. And so this gives us sine theta equals this, or 3 plus or minus root 521 over negative 32. And if we were to take the inverse sine of this, we would find, and I'm not gonna type it into the calculator and figure what that is, but if we were to take the inverse sine of this to figure out what theta is, we should know certainly that it's not pi over 2 and 3 pi over 2. And it is also not either of these. And so you don't need to worry about it being either of those either. And so then we will take each of these 4 values, now that we've shown that dx d theta doesn't equal 0 at any of these, and we can plug them in. And where should we plug them in? Plug them into our y value, since we're looking for horizontal tangent lines. So let's get a new page for that. We had y equals, what was it, 3 plus 8 sine theta times, this one is times sine theta, right? And if we're going to plug in, the first value we're going to plug in is we're going to plug in pi over 2. So pi over 2, that's going to give us 3 plus 8 sine pi over 2 times the sine of pi over 2. What's sine of pi over 2? Should be 1. So this is 3 plus 8, which is just 11 times 1, so we get 11. So our first value is y equals 11. If we do this with 3 pi over 2, our signs should be negative ones, right? So 3 plus 8 sine pi over, 3 pi over 2, and sine of 3 pi over 2. So we got 3 minus 8, so we got negative 5 times negative 1, so that should be 5. Everybody good with those two? Yep, okay. Then the other ones seem like they're going to be a pain, right? What are our values? Pi plus inverse sine of 3/16. Right, so pi plus the inverse sine of 3/16 and 2 pi minus the inverse sine of 3/16 seem like a huge pain, but what are we trying to do? We're trying to figure out what the sine of those is. Well, what is the sine of each of those? The sine of each of those angles is negative 3/16, right? Based on what we've already written out. Yep, exactly, Luke. And so as we plug those in, we're just going to get y equals 3 plus 8 times negative 3/16 times negative 3/16. And when I do it for the other one, I should get the exact same thing. So this becomes what? 3 plus, this will become a negative 3/2. So 3 minus 3/2 is 3/2. And 3/2 times negative 3/16 should be what? Negative 9/32. And I know we're just a second over here, but it doesn't take you 9 minutes to log out and log back in, right? Of course not, to another Zoom class. So let's real quickly look at the graph, and then I'll tell you that you can go. So originally we had r equals 3 plus 8 sine theta. Should probably put this back where we can see it. And we had horizontal tangent lines of y equals 11, which you can now see. Y equals 5, which is the top of that loop. And we had, what did I just come up with? Y equals negative 9/32. And I put in 2 equal signs there. Maybe if I actually put the negative, that'll look better. Yep, negative 9/32. Can you guys still see? You can't see. It says the screen sharing is paused. That's weird. I never went to Desmos. Now you can see Desmos. Everybody good? Sorry. So y equals 11, y equals 5, and y equals negative 9/32. And there they are. And I thought we were going to get done, but then Zoom had to crash, and then I had to ramble for 20 minutes. I thought we were going to finish early, but now we finished late. Let's see here.